Alright, so in this video I'm going to do a word problem using some trig. So suppose we're trying to figure out the height of our little building here, and suppose we make a couple of measurements. Suppose there's one angle of 25 degrees that goes to the top of the building. We don't know the distance from the base of the building to that angle. And then we also have another angle that's 15 degrees to the top of the building. And we know that there's a distance of 40 meters in between those two angles. So we want to use that to figure out, again, the height. So this is going to be, we'll take a couple steps here for sure. Not just a one-step problem by any stretch. All right, the first thing I'm going to do is sort of look at this 25, think about this first triangle, the 25-degree triangle. So we're trying to figure out the height of this building. So our building's, here's the left edge of the building. There it is. Let's call that H for height. Okay. The first thing I'm going to do is I would like to also sort of figure out some expression for this sort of the width of this little triangle. So I think we can use tangent, because tangent of 25 degrees, that would be the opposite, which in this case is h, over the adjacent side. Let's label that as x. And I'm going to solve for x. And what I can do is I can multiply both sides by x. So I'll get x times tangent of 25 degrees equals h. And then I can just divide both sides by tangent of 25 degrees. And I'll get that x equals h over tangent of 25 degrees. And of course, again, you could totally, make tangent of 25 degrees into, some decimal if that made you feel more comfortable. Okay, so what I'm going to do now is I'm going to think about this sort of larger triangle. So we have this bigger triangle. Okay, we knew that that was 15 degrees, right? So that was 15 degrees. We knew that part of the distance was 40 meters. That was given to us. The rest of the distance, though, we've just solved. That's going to come from the other triangle. And we've just figured that out to be h over tangent of 25 degrees. And again, we have the big height here still on the right side. So what can we do in this case? I think, again, we can relate really the opposite side to the adjacent side. So it says tangent of 15 degrees. Okay, that's going to equal the opposite, which in this case would be the height of the building, over the adjacent, which would be the 40 meters plus this additional h over tangent of 25 degrees. Alright, so again, all we're really doing is just using tangent a couple times. Again, we figured out sort of the width of the small triangle, and now we're just using the big triangle, and what we're trying to do is just create an equation that involves h. So at this point, a little bit of algebra, now we have to just simply solve this equation. Alrighty, so what I'm going to do is I think I'm going to start turning everything into decimals, just to start approximating things. I think it'll make things a little bit easier to deal with. So let's see. I'm going to do tangent of 15 degrees. So there's 15. Tangent of 15 degrees is roughly going to be 0.26. We'll round it up to 3 decimal places. 0.268. Then we have h over 40 plus h over, we'll also do tangent of 25 degrees. So there's 25, and let's do tangent of that. I'm getting 0.466. What I'm going to do next is, I think I'm just going to multiply both sides here by the 40 plus h over 0.466. So we'll have to do it to both sides here. Okay, so on the right side, everything's just going to cancel out, the 40 plus h over 0.466, and we'll be left with 1h. On the right side, I'm going to distribute this out because this is really again, you can think about the 0.268 as being out front, and then we have 40 plus h over 0.466. So let's do a little distributing here. So 0.268 times 40. When we distribute here, I'm getting this to be 10.72. And then we would get h times 0.268 over 0.466 equals h. So let's see, 0.268 divided by 0.466. So let's see, 10.72 plus, when I did a 0.268 divided by 0.466, I'm getting that to be 0.575. Again, multiplied by h, that equals h. And now I've got a nice, finely linear, I guess we had one before, but certainly a nice recognizable linear equation. I'm just going to subtract 0.57h from both sides. So we'll have 10.72 equals 0.425h. Again, I'm just taking 1h and subtracting 0.575 and getting 0.425. And then we can divide both sides by 0.425 by 0.425. And that's now going to give us the height of our building. So let me check this one real quick. So 10.72 divided by 0.425. I'm getting our building to be roughly equal to 25.22, and I think our original, did we have units? I think they were originally in meters. Where did they go? Yes, we originally used meters. So I would say the height of the building is roughly 25.22 meters.